Everything. Arnav, Sahil, can you guys hear me?
Yeah, we can hear you.
Yeah, we can.
Okay, perfect. So, welcome everyone. This is the third Java meeting in Coding Club at SFHS. So today we'll be learning about classes and functions, and then we'll do a couple more projects just to build on our knowledge. And I think at the end we have a little leak code question planned out as well. So that should be fun.
All right. So in this presentation and meeting, we'll have a recap of last meeting, go over classes and functions in Java, make an email generator, make a password generator, and finally go over a leak code problem.
So for those of you who weren't here last week, what we did is we built a simple calculator using Java. We learned about arrays, and we also we learned the basics of implementing searching and sorting algorithms. Sahil, if you want to, no, I mean, William, if you want to screen share the calculator code real quick and sort of run the people who missed it last week through it.
Yeah, so I'll stop screen sharing. The calculator was mainly what we did last week. It was like a main project, so William will go ahead and explain how that works quickly.
So basically, we had to initialize these variables over here for our two numbers that we were going to be entering into the calculator. We also initialized the character variable that would be used to designate the operation that we'd be using. Then we also used the scanner variable in order to create prompts for the user to enter the numbers. And this would basically ask the user to enter in the operation that they should use. So they would enter in the addition, subtraction, multiplication, division, and even the exponent one. So basically, here, let me actually run through it for you. So when you run it, you'll be given this. You have to type in a number, enter in another number, and do plus, and it will return a double variable, like the double answer over here. And we also learned about the math.pow function, which will find the exponential value of these two numbers that will be entered in. Let me test that out for you guys. So enter 5, 5, and that. There you go. That's pretty much it.
Okay, so that's what we did last meeting. Now I'll move on to the new content for this meeting. Okay, here you go. So, like I said, this meeting will be learning about classes and objects in Java and object-oriented programming. So, classes and functions, they're really a main part of Java because we've been somewhat avoiding them, but this is really what allows Java code to be run. So, what is a class in Java? A class is like an object constructor or blueprint for creating objects. So, if you look on the right here, this picture does a pretty good job of explaining it. So, imagine if you had a class as a person, right? So forget about like Java for a second. I'll just explain it to you in English, and then we can look at code. So if you had a class as a person, and then the data members would be kind of variables. So you could have variable name, which would be a string, age, which would be an integer, city, another string, gender would be a boolean, right? So those could be the variables of each person. So each person has the same variables, but the variables are set to different values. Like for John, for example, his age is 35, but for Desi, her age is only 20. And so they both have an age variable, but they're set to different values. Same thing with the methods. So John and Desi, because they're both in the person class, they're both people, so both of them can eat, study, sleep, and play. And this, again, can be different for each person. So John's maybe study might be different from Desi's study, and that's fine because they can both study. So that's what classes are kind of showing you in Java. So how do you create a class? Well, we've actually always had classes in Java, and we've always been using them and creating them. We've just never really focused on them. So it's pretty simple to create them. You just do public class and then class name. So I'll show you guys BlueJ right here, which is the code editor I'm using. If you want to make a class called main, And most of these editors are pretty smart. They'll automatically make it for you. So let's say we have right here, right? Public class made. It already made the class. So right here it says the format is to public. This is right public class name. And we already have that right here. Inside the class, this is when we do different methods, variables, etc. So as shown in the picture right here, I have a little code snippet. So here we have public class main, and we're just doing the general stuff that we've done before. We have variable, public static void method, which we'll learn about in the next few slides, and then methods in the system out print. So that's classes. And now methods in Java. So methods and classes in Java kind of go hand in hand. And the reason for that is because, well, if you have a class, what you put inside of it is a method, and the method runs the Java code. So, same example here. We have a method here, and this is a void method. We'll get into that later, but essentially what it is doing is it's just doing these two code statements inside of it and printing something out. So let's say if you had a method that wanted to add 5 to a number, right? So I have a number x and I want to add 5 to it. So I can just write print x plus 5, so system.out.println x plus 5. But let's say if I wanted to add 5 to y, so then I'd have to write again system.out.println y plus 5. Or what if I wanted to add 5 to the sum of x plus y? Then I'd have to write it again system.out.println x plus y plus 5. So what a method is doing is we're just going to write a method, and we'll learn how to write that in the next slide, but we'll have a method that says taking the number, whether it be x, y, x plus y, anything, and just add 5 to it, and we print it out. And so that way we're like reusing the code. And you'll see this later on. But the last thing about methods is the void method. So all programs have a public static void method. As you can see right here, public static void string args. So that's the initial method that Java just creates just to run the Java code. Okay, so as you can see here, the method allows for Java code to be run inside a class. So what are the components of a method? First, you have the modifier, and it can be public, private, or protected. And then the return type. So what value is it returning? The method name, and you follow the naming conventions for method. It's a bit counterintuitive to English because in English, if you're writing a word, you'd write the first letter would be uppercase and the second letter would be lowercase, and so on and so forth. But here, so let's say you have like 2 words, find sum. That's your method name, find sum. So find would be lowercase. So everything's lowercase except the first letter in each word, starting from the second word. So the first letter of the first word is lowercase, and then the first letter in the second word, first letter in the third word, first letter in the fourth word, those are all uppercase. And so after that, you have parameter list and method body. So we'll show the code here. So this is the modifier I was talking about. It can be public, private, or protected. And then return type. So here we're returning an integer. And then this is the method name. It's called max. And then name, obviously you name it to what the method is doing. And so here we're accepting 2 parameters, which would be an integer x and an integer y. And the body of the method, well, we're just finding the max of it. So if x is greater than y, then return x, else that means y is greater than x, so return y. And that's it. So the next most important topic when it comes to classes and methods and all that stuff is actually topics of object-oriented programming. So Java, if you didn't know, is an object-oriented programming language. We touched on this in the first meeting, but most object-oriented programming languages have 4 main topics, and because 2 of them are a bit advanced right now, because it's just third meeting, I'm just going to go over 2 of them that relate to classes and methods, which is what we just learned. So inheritance is the concept of a subclass that inherits the methods of a superclass. So, for example, if I have a class right here, vehicle, right, and a vehicle can honk, right, and it has a brand, which is Ford. So this is the superclass or the parent class. Now you have a class, which is a subclass, which is car, and extends vehicle. When it says extends vehicle, that's how you know it's a child class of the parent class vehicle. And it still has the brand and the honk function, but it also has like other things extra to it, which are not in the parent class. So it has a model name, Mustang, which is still a Ford brand, but it's a different model. And then you have another method here where you're honking it and printing the car. So this is how you are initializing a car. So you're creating a car, which is a subclass of vehicle, and then you're doing the same thing honk. And this honk is not defined in this car class, but it is defined in the vehicle class. So that's how you can honk your car. And then just a print statement at the end. Now, polymorphism is kind of like a layer on top of inheritance. So it's allowing for developers to perform a single action in various ways. So if you take a look at the example on the right, I have a class animal. And an animal can make multiple sounds, right? It's like a pig, horse, dog, cat, bird. They're all making different sounds. And that's kind of what polymorphism is the animal sound method. It's different for every animal. So right here, when you have a pig that extends animal, the animal sound for pig is different than the animal sound for dog. Obviously, you can't like make the computer make a sound through Java, so we're just saying wee wee and then bow wow for dog and pig. But that's inheritance and polymorphism for you guys. So Sahil will talk about functions now.
Yeah. So functions are a way to rerun blocks of code easily and cleanly. And to make a function, you just need to write. You have to have the access specifier, an optional static, the return, the name of the function, and then inside your parentheses, optional parameters, and then finally your code. So let's break this down. So the first thing, which is the access specifier, it's either public, private, protected, or default, which is just none. When it's public, accessed by other can be accessed by code in other classes or files. Private basically means it can't, and protected isn't really used that much, but it is there. And finally, for default, it's basically the function that can be used within the file but not outside, and it includes classes within it. All right, the next part is an optional static. Using static is basically just helpful so you don't have to write as much. For example, if you didn't write static, you'd have to have the class name, the object name of and a random object name, and then the new, and then your class name. And then finally on the next line to run the function, you need to have the original name you chose, dot, and then your function name, and then any parameters needed inside the parentheses. But if you use static, you can just write your function name and then in parentheses, whatever your parameters are if needed. The return type refers to the function. Same with methods, but in the example provided, it shows that it returns the answer of 1 plus 1 when it's added, when the function add is called, and it has a return type of int. And since 1 plus 1 is 2, and 2 is an integer, it works out fine and prints 2. Finally, the parameters are the parameters of the function. You can, for example, if you had a function on adding two numbers, instead of manually writing those two numbers inside the function, you can just use them as parameters and you're basically done. So for example, in the code provided on the bottom right, it says the add, I made a add function with parameters of an integer a and integer b, a plus b. So in this case, whenever add is called, whatever two numbers inside the parentheses, it'll just be added and returned. To make a parameter, like I said before, you just need to have your data type, your name, and then a comma if you want to add more.
All right, so for our first project, we're going to be working on making a random password generator. So actually making a random password generator is slightly tricky because you have to have both numbers and letters in the same string and you have to make them random. So the way we're going to do this is we're going to utilize something called ASCII notation, or ASCII for short notation. So basically what Java does is if you try to convert a character, an integer to a character, it utilizes this ASCII notation to see what character the number is going to become. So for example, if you see 48, if you try to convert the integer 48 to a character, Java returns it as being 0, and then 49 would be 1, and something like 110 maybe would be the letter N. So let me just share my screen. So I'll just code it out for you guys, and so you can kind of see it. So if you guys want to code along, that's fine. You can open a online Java editor, or if you have Eclipse or BlueJ installed from the first meeting, you can use that. So the way we're going to do this is, so if you look at this, between 48 and 122, there are 78 different characters, and we could start at 33, but the way I've done it is I started at 48. So you can get a random number from 48 to 122. But because Java's random function is made weird, so what it does is if you use a random function, it gets you a random value from 0 to 1 with decimals. So you have to scale that up. So here, let me just start coding this out. So the first thing you have to do is you have to make a scanner. You can name that whatever you want. I'm just going to name it in. Actually, before you do that, you have to import the scanner class. You do that by saying import java.util.scanner. So you can create a scanner after you import it with this. So you say scanner in equals a new scanner. You do it like this because the scanner is an object, which we just learned what an object was. So the scanner is an object. So what we're going to be doing is we're going to ask the user to provide how long they want their password to be. So for example, they can say they want it to be 10 characters long or 12 characters long. So we print out a line, system.out.println line, and we say, how long do you want your password to be? So this way they can specify whether they want their password to be 10 characters long or 15 characters long. And then you can say int length equals next int equals in dot next int. And what this does is it allows you to use the scanner object that you made to grab an input from the terminal. So now if you run this, oh, I forgot a semicolon there. So now if you run this, hold on. That's why you have to specify system.in. You have to specify that you want to get an input from the system. So now you can say something like 10. In this case, it doesn't do anything, but now this 10 is stored in this integer length. So then you can use this 10 however you want. In this case, what we need to do is we need to iterate through so we have to iterate 10 times, and we have to generate a random character by using the ASCII notation that I mentioned before. We have to generate a random character 10 times. But before we do that, we can create a string, just call it password, and we make that an empty string. So we can add these different characters onto the string. So now we can iterate through this. What this does is it basically runs whatever is within these brackets. 10 times because that's what we specified up here. So it iterates this 10 times. And what we're going to create a new function called get random character. We'll make that after, but for now we can just say password plus equals random character. This function doesn't exist yet, random character. We have to make that, so that's what we're going to do now. So we can make it a public function. We make it static, and it has to return a character because that's what we add on to the string. So that's why we specify that its type is of type character, and we name the method random character. So now, as I stated before, we have to create. So Java has an inbuilt random function, but the issue is what it does is it returns a float dot random. This is the random function, but the issue is that it returns a float from 0 to 1. So it'll return something like 0.1 or 0.15, 0.157, something like that. So what we have to do is now we have to scale this to the values that we want. So from 48 to 122, which is z, which is the end, there are 74 values. So if we multiply this by 74, that scales the values up from 0 to 1 to be from 0 to 74. And since we specified that this is an int, we have to do something called casting. So we convert this value from being a float to being an integer. So this right here will give you a random value between 0 and 74. But we don't want a value between 0 and 74 because there's all of these characters which can't be used in a password. So what we can do is we can add on 48 to the value that we got. So 0 becomes 48 and 74 becomes 122. And that will give you a random character between 48 and 122. So we can say our number equals random plus 48. And then we return. So this is the same thing that we did up here. We're casting the number and we're converting it into a character. So if the number is 48, the character is 0, and the number is 122, the character is z. So now we have our password. And then all we have to do is we can just print it out for the user. Print line password. Semicolon there. Now just hope I didn't make any errors. So if we say we want a 7-character long password, it gives us this, and it's 1, 2, 3, 4, 5. It's 8. Oh, it's supposed to be. We can start it off at 1 to get it to exactly 7. So now if I say 10, it gives us a random password. So we can do this as many times as we want to get as many passwords as we want. 20. No idea why that didn't run. We just try again. So yeah, that's how you make a random password. Sahil, William, if you want to go ahead and teach them the second project. William, real quick before you start, does anyone have any questions, or is everyone fine with does everyone understand how we made the password? No, I'll take that as a no one has any questions. All right, William, you can move on.
Okay, so first make sure that you have your Java IDE opened up. I'm gonna give you about 10 seconds to get that done with. Okay, so now you have to create a new Java project. We'll call it mail gen. Finish. So now you should have this open. Now you want to right click on your source package folder. Hit new class. We'll say send email. Now before we do anything else, I want you to do a few things. So you need to download some assets from outside. So let me copy the links for that. I'll put that in the general chat. So you want to download the JavaX, these two packages. Or I'll actually include it like directly so you guys can download it directly. These are all three of the files that you need to download. Just make sure that you have that first. It'll take a while for it to download, but after you finish downloading it, I want you to right click on MailGen, go to Build Path, Add External Archives. Now wherever you saved it, I want you to select all three of these, so activation.jar, javax.mail, and smtp. This will help us while sending emails. So now if you're in Eclipse, it should look something like this. It should appear under reference to libraries. So now before we do anything else, we need to import a few Java assets. So you're going to want to import java.util.properties, import javax.mail.message, import javax.mail messaging exception, import x. Has everybody gotten up to this point? And it doesn't matter if you have all these yellow errors, that's just because we haven't actually used them in our code yet. Has everybody gone up to this point yet? Okay, I'll take that as a yes. So then you want to create your main method. Once you do that, you want to initialize your variables for your email, host, and system. Because in order for the program to know which email you want to send the email from and the email you want to send it to, you need to declare it for your variables. And you also need to initialize your variables for your host and system. So I'm going to do that now. By the way, you can use whatever email you want to send it to. I'm just using mine and a fake email. Nobody coder 8 string host smtp.gmail.com, then properties properties system.get properties. Now you've initialized your variables for those. But now we need to set up the server for the mail so the program can actually send the mail. So I'm going to enter over here and set that up now. Alright, so now we have set up the mail server. And now the next step that we will be doing is making sure that you can send emails from your IDE. So the next step would be to make sure the program can log into your email account, so you would enter the username you'd be using for the program to enter your account and your password. But you cannot do this because when the program tries to log in into your Google account, this is assuming you're using your Gmail account, it will be prompted by your two-step verification and will not be able to log in. So you will need to create an app password. So let me actually change what I'm sharing right now to this. So basically what you need to do is go to your Google account. So I'll basically do a little sample. Let me go. So you're going to manage your Google account. Go into security. Now, okay, I guess we won't be able to use this, so I'm going to be using my dummy coder thing. So you're going to go into your Google account settings, go into security, click on app passwords, and then you're going to want to select the app and device you want to generate that password for. So in our case, we're going to be using other custom name. So you would title something like my app. As you can see, I've already done it over here for mine. So and once you do that, you'll be given a 16-letter app password. So once you've set up your app password with Google, you can now use it to allow your program to access your account. So now let me go back to Eclipse. Can everybody see my screen now?
Yeah, we can see it.
Yeah, we can see it.
Okay. So now what you're going to want to do is actually doing all the, make sure it can enter your account. So what you're going to do is session So as you can see here, we've created our little password authentication instance where the program will grab the username and password. So what you're going to do is whatever email address you want to send the email from, you will type that in. So I want to send it from nobodycoder8@gmail.com. As you can see here, just use whatever you have over here and make sure it's over here. And then you're going to type in the 16-letter app password we got earlier. I'm just going to use some random thing so I can satisfy that. And then once you do that, in the next step we will be using try-catch blocks. So I'm going to stop streaming and make sure we learn what try-catch blocks are first. So let me share my screen again. Make sure can you guys see it?
Yeah.
Okay, so as I said, in the next step we will be using try-catch blocks. Before we do that, however, we need to first learn what they are. A Java try block is used to enclose the code that might throw an exception. It must be used within the method. If an exception occurs at a particular statement in the try block, the rest of the block code will not execute, so it is recommended not to keep the code in try block that will not throw an exception. A Java try block must be followed by either a catch or finally block. We will be using a catch block in our case. So now that we know what they are, we can now use them in our code. Let me stop sharing my screen again and go back to Eclipse. Can you guys see it now?
Yeah, we can see it.
Okay, so now I will begin doing the try-catch block. So now you can basically put whatever you want for your subject over here and whatever you want to send in the body text over here for your email. So what this will do is basically it will tell the computer to send a new email from this internet address to the message recipient and make sure you have the internet address. Now I will do the catch block. Oh yeah, and before you do that, you need to have transport dot send message. Otherwise, the computer won't send the message, email, whatever. And now we should be done. Just save your code and run it. It won't work for me because I did not put the correct app password, but for you guys it should work. So let me go ahead and show you what it should look like. Just give me a second here. Yeah, as you can see here, it didn't give me the right thing. Let me unshare my screen. Share my screen again. Go into Google. Basically, this is a sample email of what I just sent. As you can see, I customized the subject to be Java mail, and this text is, I sent this from a Java IDE. This is what should happen when you send it. If you don't, then make sure that you have the right app password selected and recheck your code. But other than that, your code should be fine.
Here, William, could I make one quick note about this project real quick? Could you switch to the code?
Yeah, sure. Let me just.
Okay, so one quick one quick note I just want to clarify about this project was up until now we've done projects like calculators, sorting arrays, stuff like that. This is the first project where we actually integrated an API, which was Java Mail. So if you scroll down, so that's what all the import statements are doing. So if you scroll out, yeah, these all the methods from here are integrated from Java Mail. So that means we don't have to really set the methods. They're just already, we can just call them because we imported Java Mail. And, it's nice to do like make calculators, sort arrays, simple stuff like that. But I just wanted to put out here and tell you guys that in the real world, this is how most big projects are done because they don't code everything from scratch. Instead, we just use the Java Mail API in this case, which is allowing us to connect between our Java IDE and, well, Google's Gmail software. And that's how we're still programming it to connect between, but the actual connection is made and programmed. Like someone programmed that and made it into an API, and now we can just download the API and import it. And that's what William did in the beginning of this. So yeah, that's just one note I wanted to clarify about this project.
Okay, thanks. And that's pretty much all that there is to coding a mail generator with Eclipse. So let me unshare my screen. And yeah.
All right, I think we have a little time left. I think we can start off with the lead code problem. So let me share my screen real quick. And for those of you that don't know, what lead code is it's basically a website that allows you to get practice problems to sort of understand how to write algorithms and data structures, and they prepare you for interviews from big tech companies, stuff like that. So this is just I have a solution. Let me just delete that. So it's just a problem. It's called the minimum path problem. It's ranked medium, so it's pretty difficult. There's also if you guys want to practice this by yourselves, there's easy problems you can do. For those of you doing use of code, this might be very helpful. So here's the problem statement that we have. So given a m by n grid or matrix, and it's filled with non-negative numbers, we have to find a path from the top left, so from right here, to the bottom right, which minimizes the sum of all the numbers along its path. And we're only allowed to go down or right at any point in time. So here's the example one. So this would be the shortest path because it gives you 7, while others would give you higher numbers. For example, if you tried to go this path, that would give you 2, 6, 8, 9. So that would be greater than 7, so you couldn't go along that path. So I'll give you guys a couple minutes if you guys can think of any ways to do this, any solutions. Just go ahead and either unmute yourself and tell it out, or you can type it in general. Just give you guys a couple minutes to think over it.
Also, one more thing is, if you guys remember from last meeting, we touched on the time complexity. So when you guys are thinking of these algorithms, it's fine if you can get it to work, but like generally, you're trying to get it to work in the least amount of steps possible, just so the efficiency of the program is like as high as possible.
Yeah, also, I'm pretty sure LeetCode ranks your algorithm and how you did it based on how the others did it. So you can also use that.
And Arnav, if you don't mind, you can send the Elite Code link in the general chat so everyone can access it.
So if you guys want to code along while I do it, you can do that as well. I'll start writing an implementation at 4:50. Right. So again, this is a medium problem. So if you guys couldn't find a solution to it, that's completely fine. You can look at easier problems to do in your free time if you want to get better at writing algorithms and problem solving. So because we're told that we're only allowed to go down or right, what we can do is we can rewrite this matrix based on the sums of the previous cell. So for example, we're given this, right? So the first step we would do is we would rewrite all of the values in the top row. So this would become 4 because you would add 3 with 1. And then this would become 5 because you would add 4 with 1. And then you would add up all the ones in the outermost column. So this would become 2. And then this would become 6 because that would be 4 plus 2. And the reason that we do the outer ones first is because the outer ones aren't influenced by any by two cells. They're only influenced by the one before it. So for example, you can't do this one because you're not sure whether this one would have a lower value than this. So once you rewrite these the outermost column and row, and you get these values, well, you have to update the ones on the inner side. So you have to update the values of these cells right here. So you know that this value right here equals 4, and you know that this value right here equals 2. So obviously the shortest path for this would be to go this way instead of going around like this, because that would give you a greater value right here than going this way would. So then you would add this cell with this cell right here, because you're only allowed to go right and down. So then the value of this changes from 5 to equal 7. And then you do the same thing for this. So you check the 7 with this value right here, which is 6, and this is shorter. Well, this is smaller than 7, so you go down this way, because the path would be shorter to go this way than it would be to go this way. So now this would equal 4, 5. This would equal 6. And this is 7 right here. And now you have to do the same for this value right here. So this is 6, and this is 7. So the shortest path would be to go this way. So you add 6 with 2, so you get 8 right here. And then since this is 4 or 5, this is 6, and 6 is smaller than 8, this is your shortest path. So 6 plus 1, which is 7. And that's our output here. So that's the basic algorithm. It's similar to an algorithm called breadth first search, if you guys want to look into that. It's a very similar algorithm. It's just the way that it's written is slightly different, because breadth first search works with the graphs and pathfinding. This is pretty similar. So our first step is to define two integers, which tell us which give us the values of m and n right here. So we can say n equals grid dot length. So dot length basically gives you the length of an array. So if you have just this top part, because we can think about a matrix as being a 2x2 array. So if you just take grid dot length, you have 3 arrays within grid. So n equals 3. And then you also make one for the number of columns. So n is the number of rows, and m would be the number of columns. So m equals grid with an index of 0 dot length. So this grid with an index of 0 basically gives us the first element within grid, which in this case is this first row right here. That's the first element, and the length of that is 3. So then m is also equal to 3. So the first step we should do is we should rewrite the values of this outer row right here. So to do that, we write a for loop to iterate through this, and just add this value to this and to update this value. So you can say for int j equals 1, j is less than n in this case. Or well, no, you would use m because m is the number of rows. And then you can say j plus plus. And now what you have to do is you have to write a statement so that this 3 value here is added to this 1 and it gets updated. So to do that, what you can do is you can say that the grid value at the point 0j, since j starts off at 1, we're talking about this element right here, that equals the grid value at index 0j minus 1. So that refers to this value right here, plus the grid value at 0j. So what this does is it basically takes this 1, this is 1, and this is 3, and it adds the two of them together to make this 3, 4. And then on the second iteration, 0j becomes this because now j equals 2. So this is this right here, and this 4 is this. So you add the 4 to the 1, and this becomes 5. So that updates this outer row. Next, what we do is we do the same thing, but now for the for this outer column. So we can say int I equals 1. It's basically the exact same thing, but this time we use I is less than n because n specifies the number of rows, and you want to go the rows, so you want to go down the number of rows. And then I plus plus to iterate through it. And now it's basically this exact same statement, but instead of it being 0j, it has to be I0, so that refers to the first column, and you move through the rows. So you can say the grid value at index I0 equals the grid value at I minus 1, 0. Before I do anything, let me make sure I put a semicolon there. And then we add the value of grid I 0. So what we're doing here is grid I in this case is 1. So the value of grid at 1, 0 is this. And then we take the previous the one in the previous row, which is this, and you add the two of them together, so this becomes 2. And on the next iteration, you add 4 and 2 together, so this becomes 6. So what that does is that updates this outer row and this outer column for us, and the only thing we have left to do is to update these. So to do that, we have to write what's called a nested for loop. So we have to have a for loop within a for loop because we're moving along 2 dimensions and not just one like we were here. So we can say for int I equals 1, I is less than n, I plus plus. And then we write the exact same thing, but now for n to move between rows, int j equals 1, j is less than m. Oh, sorry, I meant m, so you can move between columns, and then j plus plus. And then here what you do is you say that the grid with value I, j, we can do some, instead of writing equals that plus whatever value, you can just do something called plus equals, which is just short form for equals this plus some value. So if you did plus equals 1, that would just add 1 onto this value. Of course, that's not what we're doing because we have to add the minimum between this value here and this value here. So to find the minimum, you could write an if statement to compare the two and then add it. But Java, the math library within Java, has a handy function called math.min, and that just finds the minimum for you. So in this case, we have I as being 1 and j as being 1. So 1, 1 is this value right here, so 5. So to see which one of these adds on to the 5 to transform it, we have to check the one above it and the one to the left, because again, you're only allowed to move down or right. So then you find the math.min of the value. This is the one to the above it. So I minus 1, and then j, and then grid at the value I and j minus 1. So this one gives you the one to the left of it. So this updates all of these values on the inside, and then it updates this value finally. So it goes here, then it goes here, and then here, and then it goes here, and then here. So this is the final one. So since it asks us to give it the sum of the shortest path, this value right here is whatever value is here in the transformed matrix. So to do that, we simply just return the grid value at n minus 1 and at m minus 1. So that, because m and n are 3, but the coordinate here is 2, 2, because Java lists start off at index 0 and go upwards. So you can't use 3, 3 because that would say that the index is out of bounds. It would give you an error. So you have to do n minus 1 and then m minus 1. Let me make sure I put all my semicolons because I don't want to throw an error while running the code. And now if we run it, that should give us the answer 7, and that's what it expected. So yeah, that's how you solve the minimum path sum. Again, if you don't understand this, it is fine. You can work your way up to understanding it by doing easier problems. And you can also look into the algorithm called breadth first search to sort of get an understanding of how I did this.
Yeah, other than that, that's all we really had planned for today, and we're at 5 o'clock. So thank you all for joining. You're free to leave now. And yeah, hope you learned something.
Have a good day, guys.